All right, and also I have resynced grades, so they should be, uh, pretty much up to date with all of that, and we're going to talk a little bit about that today as well. So take about 5 more minutes. Make sure you're looking up um, the rules. Honestly, it might be easier just to look up rules for naming assets than going back and finding it um, in Canvas, which I'm sure you guys are not doing. You're probably just Googling it, but um, make sure that you kind of have an idea of that before we start. All right, um, much we got a much better response group the second time that we went through. I'm not super upset about us not being able to name acids. We only went over it very briefly, and it was something that we went over kind of like right before midterms and things like that. So we're going to actually go back and talk a little bit more about that, and that's part of the reason why we're going to do a little bit of review of things that we actually went over previously, because the goal for us is, especially with regards to acids, to know a little bit about them, acids and bases. Okay. The This right here is used in a lot. Oop, not that one. Yeah, this right here is basically the #1 industrial chemical in the world. Okay. Sulfuric acid is used for darn near everything. Okay. Hydrochloric acid is in a few things, but it kind of makes poisonous clouds. So we try not to use it as often. Okay. Barium hydroxide and sodium hydroxide is cleaning. And it's typically sodium hydroxide that's in the cleaning supplies, but um, it's kind of important to know these things and to be able to identify the difference in um, the chemical makeup of these things, because um, obviously bases and acids are both damaging. If you get a really strong base on your skin or a really strong acid on your skin, and we have talked about that. But there are two types of acids, and we're going to very briefly review that again today. And there's basically just one type of base, and so we'll go through that and look at it. couple of things. First off, everything that is old, all old work is going to be due on the 11th. Okay. Also, we are going to start doing review. Okay. And part of your review stuff is basically going to be, you know, a way for you to get a lot of credit. Okay. And bring your grades up dramatically. It's going to be formal and things like that. So we're going to go back and kind of re-practice some things, and it's going to be structured where you have a little bit each day. And you know, that's kind of what we're looking at for that. But some of y'all may have noticed that your grades went down as a result of not doing the last project, or you know, that they're not where they're supposed to be as a result of you just, you know, not doing everything that you're supposed to be doing. You have until the 11th. After the 11th, everything is going to be makeup credit. Okay, so you need to make sure that that's, you know, a real priority for you. And you know, I don't know if most teachers will say, but if you have a good grade in here, focus on, you know, class you don't have, you know, as good of a grade in. Okay, those are all skills that you guys need to know. So we're gonna go through. I'm bored of this color. Let's do another one. You have two types of acids. Okay, you have what is called binary. Okay, which is literally what it sounds like, two compounds together, and that has its own naming rules. Okay, remember we talked about hydro and no hydro. Okay, if you you know, were paying attention back then, some of you weren't even enrolled in class back then, but it is, you know, something that we went over. Okay, and then you have ternary. Okay, and all that means is it's going to be a hydrogen plus a polyatomic ion. Okay, and the rules for naming that are different. Okay, so for binary acids, you have to basically put hydro, whatever the chemical is, and then ic, acid. All right, so for this one, a lot of people put hydrogen chloride. You even see that written in some, you know, texts and things like that. That's not what that is. Okay, so this is hydrochloric, move this window out of the way, acid. Okay, that's hydrochloric acid. Okay, and so anything that's a binary acid, you have to add the hydro to. A ternary acid, you do not add hydro. So what a lot of people are going to try to do is say hydrosulfuric acid or hydrosulfuret or sulfurous acid. That ain't what we're doing. Okay, so when it's a ternary, you do not put hydro, and so this one would be sulfuric acid. Okay, and it is it's ubiquitous. Okay, that's a SAT word. All right, I've been teaching SAT words. That's what I've been doing the last couple weeks, couple days. It means it's everywhere. Okay, but it is something that, you know, is pretty important to know about. Okay, OH. If you remember OH, anything that is OH is a base. Anything with a hydrogen in it by itself is an acid. Okay, so for those of you who put acid for the first two and base for the second, you are correct. Okay, and so when you look at this, all you do with these, remember we talked about naming polyatomics, and we are going to go back and review this stuff. Okay, because even though we don't have a final, chances are most of you guys have aspirations above or you know, beyond high school. Okay, and so we're gonna, you know, make sure that you have actually learned this content, because that's honestly what I care about more so than, you know, what your final score was or whatever the situation may be, even though I know we're all on our computers and we're just kind of, you know. But for this, all you have to do for these is you put the name of the first element and then you just put hydroxide. Okay, so sodium hydroxide, Drano, things like that, drain cleaners, oven cleaners, stuff like that. And then this guy is barium hydroxide. All right, and so it's pretty simple. And you got to make sure you swap and drop the charges. And we also talked about that. All right. So today we have a couple of things, one of which is a grade. Okay, and remember that you guys also have your weekly grades. I don't think I was waiting to put those in until y'all did your warm up for today. Okay, but your weekly grades are going in. This video I think I had up, and I played one of the acid videos that I have, but this is kind of interesting to see what actually happens with a piece of chicken that you put down in different types of acid. Okay, but that's an engaged thing. This is the practice. Okay, if you look at this is a buttload of work. However, what you see underneath it, it's in bold, underlined, all of that. It says we are only doing page 1. So when you click on it, all right, it comes up. It's got your Google interface or whatever, so you can click on that. Okay, you have the names, the formulas. Okay, remember we got to swap and drop. Okay, and then we're going to do pH calculations. Okay, so realistically, you only have like 15 problems. If you look at this, you'd be like, man, he is on that good dope. Like, what is going on here? No, we're not doing all of that. Okay, we're only doing one, and it's going to be one of your last grades that you had before we do our final reviews and stuff. Okay, so get that out of here. Before we do that, though, we need to go back and review a couple of things. Okay, so first off, I'm going to very briefly go in, and this is something that we're going to kind of skim through because we've already kind of done it. Okay, but I wanted to review it just to make sure that we have an understanding of it because it does actually have a practical use. Okay, knowing what is an acid, what is a base, what's going to clean things the best. Okay, my classroom looks like a bomb went off in here right now, but that's just because I keep finding new toys to play with. But it normally is very clean, and you can use certain cleaning products to get certain things up and stuff like that. So check it out. Okay, acids taste sour. Okay, and they are electrolytes. If you remember what we talked about with electrolytes, they completely basically are dissolving in water, and they're going to conduct electricity. All right. And so there are basically 6 strong acids that you guys need to know about. And those will basically completely dissolve in water for the most part and obviously produce a lot of heat, but they become electrolytes. Okay, so here's what happens. Acetic acid is a weak electrolyte, so it doesn't light up. All right. But what you're going to be able to tell, especially any labs that you do in college, or any labs that you do in biology or AP biology or AP chem or anything else, depending on what you want to do, you are looking at phenolphthalein as a indicator. If it is a base, it turns pink. If it is an acid, it turns clear, right? Okay. And then the other thing, ideally, when we come back, we'll be able to do, unfortunately not you guys, although I might invite some of you guys to come and watch me blow the heck out of stuff. But acids react with metals to form gas, okay? And normally what happens when you do this is you light it and it goes beep, and it creates like a really high-pitched noise and makes a pretty cool explosion, okay? The other thing, if you spill battery acid or you spill whatever, and I know I told you guys about incidences where I've had to deal with that, okay, or if you spill a really strong base, you neutralize it not by pouring more water on it. Spreads. Okay, what you do is you put a base on it so that it will turn it into water and salt. Okay, and this is kind of the equation for that. Okay, bases, they feel slippery. Most soap, okay, and we talked about historically, lye soap, Lye, is really, 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 really harsh, but it's also very, very, very effective as a soap. And they rendered it from animal fat originally. Okay, but pretty cool. Litmus paper turns blue. Okay, phenolphthalein turns pink. Okay, and that's going to be things that you see. Not super important in the grand scheme of basic high school chemistry, but it is something that you deal with. All right, they don't react with metals. You put something in a metal, okay, and or you put metal in something, and you can basically determine whether or not it's an acid or a base from that, okay? And you can actually Google soda test, like soda rust test or soda metal test, and you can see where they put metal down in soda and what happens to it. Pretty cool. Now, naming acids, okay? When you dissolve acids, they basically have hydrogen ions that are going to be, produced. And so what you're going to look at is you have hydro, ide goes to ic, okay? So as an example, hydrochloric, okay? That's the one we did for the warm-up. Hydrosulfuric. Come on. All right. And so you have hydrofluoric, hydrophosphoric, okay, and that kind of thing. And if you're going the opposite way, anything that's hydro means it's a binary acid, okay? And we've gone over that. All right, but this is something that if you're writing the formulas, you've got to swap it and drop it, okay? If you need help remembering how to swap and drop and what the specific charges are, okay, we can go through and talk about that. All right, but this type of thing is pretty simple, okay? Bromine is in the very, very far right, okay? It's in the group right before the noble gases, so it's a -1. Hydrogen is on the far left, it's a +1, okay? Since they cancel out, you put them together and you're done. Hydrobromic acid, okay? Hydrotelluric acid, same thing, you just gotta have a different charge, okay? It's in the same row as oxygen and stuff, okay? So you'd have H2Te, where you swap it and drop it, okay? And I'm intentionally going quickly through that because I kind of want you to have to go back and look it up, okay? Because it's going to help you to remember it a little bit, okay? Now, naming acids. You cannot put ic acid on everything, okay? And so if you remember, polyatomics are on page 7 of your reference table, and it's something that's pretty important to but for our purposes, it's something that we're going to use to, basically do this. So if you see nitrate or ate or ite, you are basically going to know that it's weird and it's a ternary acid. So NO3 is nitrate, so it would be nitric acid. It is nasty. I've got some in the room down the hall. It is really nasty. Like, you can't mix it with other acids. It's got to be stored by itself. You put water in it, you got a problem. Like, it's pretty nasty. They had it sitting in there before I fixed it. Nitrite, NO2, okay? You're going to change that to OUS. So it would be nitrous acid, okay? Nitrous. Phosphate, okay? Phosphoric acid, all right? Those are the differences. Right? I'm skimming through that very quickly on purpose. Carbonic, the most common, and that's where acid rain is from, because you have carbon dioxide mixing with water. And then you have sulfuric. We already talked about that one, okay? Get out of here. Same thing, you got to swap it and drop it. We already talked about that. We're not going back into that again. All right, so we talked about molarity, okay? And so the reason why we do this at the same time, okay, is that the concentration of the acid is basically a measuring stick of the strength, right? So it's how many moles of hydrochloric or how many moles of sulfuric or whatever are present in this amount of water, okay? So when we go through, dilutions are incredibly important for acids. And like I said, I buy really strong acid and then dilute it to what I need, okay? It's way cheaper than buying like 1 molar acid. You're basically paying for water, okay? So this type of thing is pretty basic, okay? And that's kind of a review of the stuff that we had learned or we have learned that relates directly to acids and bases. Now, the stuff that is new, okay? The stuff that is new. Thought this was a, what you call it? Here, I'll download it. Thought this was a Google slide. Hold on one second. All right, so when we talk about pH, you guys definitely have heard of the pH scale, okay? And, well, I would hope. And your bodies have a very, very, very specific pH. If your blood becomes too acidic, okay, even by a little bit, and it's very hard because you have what are called buffers in your body, you die. Your blood basically curdles like milk, okay? And so one of the experiments we typically will do, and I always used to do in biology when I taught it, was we would do lemon juice and milk. Because lemon juice is slightly acidic, it denatures the milk proteins and it causes it to curdle. It's pretty weird and it's pretty nasty, okay? But what you're gonna see is that based on the concentration, that's directly proportional to your pH, okay? So what that means is if you have a certain concentration of ions, it's going to lead you to your pH. So up until this point, you kind of know a low pH is acidic, a high pH is basic, okay, and that sort of thing. But now we're kind of taking it a half step further, okay? And so you have strong acids and weak acids, okay? Kind of like what I talked about, strong acids will completely dissociate in water, okay? Dissociate means to break up. So if you have dissociative identity disorder, that's multiple personalities. That's and they change the names and stuff every few years, but that is the scientific terminology for having multiple personalities, okay? Weak acids don't dissociate completely. There are 6 that you guys have to worry about, okay? Will you be asked about that? No. But you have hydrochloric, hydrobromic, hydroiodic, sulfuric, nitric, and chloric, all right? They completely break up. Now, pH is a logarithmic scale, okay? I saw several of y'all are in pre-cal, several of y'all are in, Math 3, things like that. At some point, you have heard of a logarithm, all right? I would hope. I don't know what they teach y'all sometimes in math around here, but logarithms are a representation, okay? And it's going to go from 0 to 14. We already know that 0 to 7 is acidic and 14 to 7 is basic, okay? So what you're going to see is that pH is the negative log of the concentration of hydrogen ions, okay? And I talked about it a little bit, but what this means is concentration, okay? Brackets means concentration, all right? And so the other thing you'll be able to see is that the concentration of hydrogen is 10 to the negative pH power. So you're kind of like, oh, Christ, I don't know what he's talking about. Listen, all you really have to do is do negative log of the concentration, or you do 10 with a little caret and put the pH in there, okay? So we'll be able to do that, and it's going to be pretty simple to go through, okay? So check it out. If you find the pH of a solution, we get this writing off of here, okay, with the H plus concentration of 10 to the negative 6. Okay, so most people have phones, okay, and most phones have a calculator, right? Well, nowhere on here is logarithm. Oh, look, when you turn it, okay, it goes, and I think log's on here. Yep. Okay, so log is right here. It says log 10, okay, and it's in the middle. So what you do is you go 10 to the, oh, I gotta find a little caret. Oops. 10 to the negative 6. Okay, and then you hit log. Okay, and so when you hit log, okay, you got negative log of 10 to the negative 6. Okay, and what that ends up being is a pH of 6. It's slightly acidic. Okay, so if you need help with this, and I'm kind of intentionally skimming it because I want to make sure that we, have time to actually do it before the, the weekend. But the negative log of the concentration is the pH. Okay. Now, the setup, 0.3 molar solution. Okay. What you have to do, the opposite, right? We have pH equals the concentration times what you call it? Oh, the to the power of the pH, and that basically equals the same thing as the negative log. Okay. So when you do this, to find the pH, you go negative log of 0.03, negative log of 0.03, and your calculator will literally spit out what the pH is. Okay, but you have to put negative. Okay, negative. You got to put negative in there. Okay. Now, there are also tools on the internet. Okay, if you're not confident doing it with your phone, okay, where you literally, there are graphing calculator apps. Okay, there are, you know, a number of different things that you can do, okay, to be able to identify and go through this. Okay, and so here's the other one, the concentration. If you're looking for the concentration, it's the opposite. Okay, you do 10 to the negative pH. So 10 to the negative third, 0.001. Okay, it's very simple. I can help you with the math independently, but again, it's just one of those things where you can do it in your calculator. Okay, pH is the opposite of POH. So the POH and the pH always equal 14. Okay, and so POH is something you may not have ever heard about. Okay, it's basically the concentration of hydroxide instead of the concentration of hydrogen. Okay, so what you're going to see, same formula, same thing. Okay, there's nothing different about it. The only difference is it's the opposite. So, you know, ordinarily in ordinary non-Rona years, we would have, hey, what is the, what is the pH of this substance if the POH is 6? Well, the pH is obviously 8. 6 plus 8 is 14. Okay, but we're not going to necessarily go through that and learn that this year, okay, or this semester because of, you know, time constraints and things like that. So the equations are the same. Guess what? The equations are also listed on your reference table, okay? So if you go to the formula page on page 2, all right, it's kind of towards the bottom, but you have pH and POH, and it's the concentrations, okay? So it's not even something where you'd have to go back and look necessarily at the notes. You could get the reference table and pull that up, okay? So same thing, same thing, same thing. Don't care about that, okay? So we flew through that, all right? And so one, because partly it was a review, but secondarily because it's something that I want you to go in and have a little difficulty with, right? So we're going to go through, and you guys are going to go through and make sure that you have a pretty decent understanding of that, okay? And your work today is this acids and bases practice. However, if you owe me something, that is also the work that you need to get done. Okay. And again, we are only doing the first page of the acids and bases practice. All right. We're not doing the other stuff. So go ahead, get started on that stuff. All right. Remember what your formulas are. Okay. You either have 10 to the negative pH or you have negative log of the concentration. Okay. Go ahead and get started on that stuff, and I will be available. I'm anticipating probably some questions because of the speed that we went through it. Okay. But I'm here for that. Okay. Let's go.